All right, up until now, we successfully added the import path of the material package from the Flutter framework. This allowed our program to recognize the runApp function, which we've incorporated into our main function. But here, let's dive a bit deeper. Have you asked yourself how exactly our code gets executed on devices like Android, iOS, or even desktops? Let's uncover the magic behind Dart's compilation process and see just how your app comes to life. First things first, it all begins with writing Dart code in your Flutter project. This is where you define what your app does and how it looks, using all sorts of Flutter widgets and libraries. Imagine you're crafting the blueprint of a building. That's what you're doing here, but for your app. Next up, we compile this code. Now, this isn't just any compilation. It's where Dart shows off its flexibility. When you write your Dart code, it is first converted or compiled into a language that your device's processor can understand. This step is vital for performance, as compiled code runs much faster and more efficiently on devices. Dart employs a just-in-time compilation process during development for quick builds, and an ahead-of-time compilation for releasing your app, ensuring maximum efficiency when your app is running in production. The just-in-time compilation can be seen as real-time translation because it happens while the program is executing. This type of dynamic compilation occurs as the program is being used, which is especially useful during the development phase. This method enables faster builds and immediate code testing, which is invaluable for developers looking to iterate quickly and efficiently. It also supports features like hot reload, where changes in your code can be viewed almost instantaneously without needing to restart your app. It's like giving your app a quick refresh and instantly seeing the updates. Indeed, as we will explore in the coming lessons, hot reload is one of the most significant features of the Flutter framework. It allows you to make changes and modify your app as much as you want, seeing the changes in a fraction of a second. This is incredibly important for us as developers. But what happens when you're ready to release your app to the world? This is where ahead-of-time, or AOT, compilation steps in. Dart switches from just-in-time compilation to ahead-of-time to prepare your app for production. In ahead-of-time compilation, Dart translates your high-level code directly into native machine code for each platform, whether it's Android, iOS, or even a desktop operating system. This native machine code is what actually runs on the device, and because it's highly optimized for that specific platform, it makes your app incredibly fast and responsive. Essentially, ahead-of-time compilation ensures that your app performs well by leveraging the full capabilities of the hardware it's running on. Once we have our native machine code, it's time to package it up. For Android, we wrap it into an APK or AAB file. For iOS, into an IPA file. And for desktop platforms, into an executable file like an .exe for Windows. Think of this as wrapping a present before giving it out. It needs to look good and be ready for use. All right, now comes the exciting part. When you launch the app on a device, the native machine code we created takes the stage. It runs directly on the device's operating system, interacting with platform-specific frameworks to render your app's UI, manage inputs, and handle device resources. And guess what? Flutter's engine, crafted in C++, plays a key role here by using platform channels to bridge your Dart code with native code functionalities. Even after your app has started, there's still work being done. During runtime, Flutter's framework keeps everything running smoothly, managing the app's state, user interactions, and ensuring all visual components are top-notch. All your updates and interactions are handled seamlessly thanks to Dart's efficient event loop. It's like having a great manager in the office, making sure everything's running perfectly. What's fascinating here is that Dart is designed to optimize this compilation process. Once the main function is executed, Dart ensures that all necessary initializations are handled. This includes setting up the environment, loading the required libraries, and preparing any services your app needs to function correctly from the moment it launches. As you can see, this automated process not only simplifies development, but also enhances the performance and reliability of your applications. Now, coming back to our code, inside the main function we call runApp, which is a crucial step in activating a Flutter app and getting something visible on the screen. runApp instructs Flutter on what UI elements should be displayed. Here, as you can see, we're encountering a new error. It tells us that one positional argument is expected by runApp, but 0 arguments have been found. This error brings us to a vital concept in programming: understanding what arguments are and specifically what kind of argument is expected here by runApp. Great! Have you noticed how each piece of the puzzle is coming together to form our Flutter app? As we continue, we'll dive deeper into arguments and see how they help us define more precise behaviors for our functions. Let's tackle this new challenge in our next step. Stay tuned, and let's make our app not just functional, but also interactive.